want to continue a discussion on exponents, and I'm introduced to the concept called the radical. And here you see listed properties of exponents that we talked about in my last video. But today I want to introduce a new property of exponents. So we saw what to do if an exponent is an integer or a natural number. But what if I had something like this, a rational exponent? So a to the 1 over n power. What does that mean? Another way of writing this is like this, and we call that the nth root. And this symbol here that I'm highlighting in yellow, is what we call a radical. So if you hear someone talking about radical equations or radical functions, they mean something that involves that roof-looking symbol. Okay, now what do we mean by a radical? So we say that the nth root of a equals b if b to the n power equals a. Alright, so let me say that again. We say that the nth root of a equals b if b to the n equals a. So what we're saying here is that we're doing the opposite effect of the exponent that we took. So as a quick example, if I said the square root of 16, well, the square root of 16 is 4, because what we mean here is we actually meant we didn't write the 2, but if you don't write the 2, it's understood. We're saying that's 4 because what we mean is that 4 squared equals 16. That's where we got that. So another one that you may see commonly is if I write, this is read, the cube root of 8 is 2. Why would that be? Because 2 cubed is 8. So as a third example, let's try something like this, the square root of negative 16. Now if I'm trying to figure out what that would be, I need to think of two things that multiply together to give me negative 16. They have to be the same thing. And so sometimes students say, well, I think that's going to be negative 4. But if you notice, negative 4 times negative 4 is not negative 16. So that cannot be the case. That is not an answer, okay? So what do we do then? Well, if you think about it, there's not something that multiplies by itself to give me a negative number, okay? So we need to add a note here. So if n is even, if it's an even number, then the nth root of a exists only if a is greater than or equal to 0. Because you got to think, the only reason that the nth root of a would exist if something can be multiplied by itself n times and get that. So if we have a negative number and you multiply by itself an even number of times, you're always going to have something positive. So this makes sense. I'm going to go over some examples and hopefully this will make sense. Okay, so here are my examples here. I want to simplify the following radicals. Alright, so in A I have the cube root of negative 64. So the answer to this is something that when I multiply it by itself 3 times, I end up with negative 64. So you might want to play around with it a little bit. If I try negative 3 times itself 3 times, I get negative 27. How about negative 4? Negative 4 times itself 3 times gives me negative 64. Alright, in B part here, I have to the 1/4 power. That looks confusing at first, but remember that means the 4th root of 81. So now I'm trying to think of something times itself 4 times gives me 81. I'm thinking 3, because 3 times 3 is 9, times 3 again is 27, times 3 again is 81. There it is. Now in C part, I have the 4th root of negative 81. And so we're tempted to say negative 3, but remember, this is an even radical. Even radicals only exist for even numbers, so there's none. There is no 4th root of negative 81. Alright, now part D, we have the square root of 0. So what times itself 2 times gives me 0? How about 0? 0 times 0 is definitely 0. Part E, we have the 11th root of 1. I don't know many 11th roots, but I do know this one. Because what times itself 11 times gives me 1? That would be 1. 1 times itself 11 times in a row gives me 1. Okay, the cube root of 64 over 27. So here I'm going to use some of my properties of exponents. Because remember, this is the same as 64 to the 20 over 27 to the 1/3 power. And we saw that that means 64 to the 1/3 over 27 to the 1/3. So that means I have the cube root of 64 over the cube root of 27. We already did the cube root of 64. We know it's 4. And the cube root of 27 is 3. So 4/3. So I didn't really need all this stuff in the middle. I just wanted to highlight that I can do that with my properties of exponents. I could have gone straight from there to see that the cube root of 64 over 27 is 4/3. Okay, now in part G, I have the 7th root of 2.1 to the 7th power. I don't know what 2.1 to the 7th power is, but it doesn't really matter. Because if I take the 7th root of something to the 7th power, it's like they cancel out. In fact, we could have a property, we're going to write it in a second, because look at the second one now, our part H. We have the square root of -6 quantity squared. So if I follow the same logic as part G, maybe I just want to say it's -6, but remember the square root can't be negative. So notice here that this is -6 squared is 36, and the square root of that's going to be 6. So the property we could write here is that the nth root of a to the n equals the absolute value of a. So if that's the negative value, you just take the absolute value like we did in part H. If it's positive, you can just drop the square root or the radical. Okay, I hope this makes sense. If you need any help, please let me know. I'd be glad to help. And thanks for watching.